Whoa, that's loud. Okay. All right, class, we are continuing on with 1.2. We did the first problem last time. So we're just going to continue on with this one here. So notice real quick here, I do want you guys to notice this thing. So the time where this guy intersects with the y-axis, what we do is we say, hey, you know what? That is going to be the point called, I don't know, what do you guys say? 0, -1, intersect. Perfect. And this point right here is going to be called x-intercept. That's perfect. Coordinates are?
4/3 and 0.
Yeah, it's this guy right here, huh? 4/3 0 or 4/3 0. So notice real quickly here, I know you know this already here. If I were to do any other y-intercept, what's going to be the common theme along the y-intercept? 0 for x, and then you get a y value, whatever that y value is for the y value. Good. Same thing here. Whatever x is going to be, x-intercept, it's always going to be x and a 0 there. We good? So let's use that to our advantage. So let's jam with number 12. Find the x and y intercepts of the graph of the equation. Now, I don't want to graph this guy. I just want to find the x and y intercepts. That's it. So I'm trying to find the x-intercept. All I have to do is put a 0 in for the y value. True, true. That's cool. Plug that in. Tell me what you get. Boy, Noah, you'd have to move then. Move somewhere like right here or here. Yeah, guys, get yourself in comfortable position to read the screen if you need to. Okay. I think so. Yeah, y goes to 0. I got this right here in my hands, and then I got to solve for x. Good old algebra 1 now. Subtract 8 from both sides. Divide by -3. And how about a positive 8/3? X is equal to 8.
Can you also just add 3x to both sides?
Yes, absolutely. So the other way to do it, add 3x to both sides, divide by 3, and you got yourself. Same thing. Good there. Any other questions on that one? Okay, that's so then if I'm trying to find the x-intercept, I would have to label it now. So x-intercept colon or equal to, if you like, whatever, but it's going to be 3/8. You can write it like this. You could write it like this. One of two ways. Over there. Okay, jam the other way here. So y-intercept is going to be x is equal to 0, and that's a nice easy one because that little x goes to 0 and y equals 8. One of two ways of writing it. Say this is the y-intercept. Y-intercept equals, I guess equal sign or colon doesn't really matter. One of them, you just write it like this, or it's going to be, this one's, we're going to be pretty fast. We should be able to get through most of the lecture here. We know it a lot better. Okay. Okay, tell me if I'm going too fast. Otherwise, let's jam. All yours for this one. Same, similar process. Go for it. Can you find me the x-intercept? Can you find me the y-intercept? Done. Hopefully. X-intercept first. Y equals 0. Awesome. How about 0 squared is x plus 1? How about this? And then how about this? -1? Tell me if I'm going to go a little bit sloppy. There's that. 0 plus 1. Ooh, anybody, what you guys do here? Noah? Took a square root of both sides. Awesome. And if we do that, we put plus and minus here. We get plus or minus 1. How fun. This guy has 2 intercepts. So how about y-intercept? Plus or minus 1 this time. Are we good? We could, but we do have both of them. So we know if we were to graph this, now this is beyond, this is Noah's question here. That means we have y equals, y-intercept is here. One second here. 1 second, let me think about this just for a second here. Yeah. Okay, so that means we have a y-intercept that's here. We also have a y-intercept that's here. And then we have an x-intercept that's right here. Here's your, I know the graph goes through those 3 dots. How does it go through it? Don't know, but I know at least it goes through those 3 dots because those are the times it hits the intercepts. Okay, good there. Jam, let's keep on going. Oh, this is fun. Okay. Well, this is when we actually had chairs together in pairs, not anymore. So I have a circle. I have a circle inside a x and y coordinate system. Question to you guys is this, and do it yourself first, then check with the neighbor next to you. But I want you guys to do this here. Can you graph the following circle? Right here, it has no intercepts whatsoever. Can you think about all the possible number of intercepts for a circle graph? Can you graph them? So give me all the scenarios. So this one is 0 intercepts.
So you're saying one move up to how many?
Yeah, up to how many, and then can you draw every single one of them? So it should be pretty easy. So draw it yourself first before you look at your neighbor's paper, and then you look at your neighbor's paper. Cheating already. Now you can look at your neighbor's paper today. Don't look during the exam. That would not be good. So graph for me a circle inside the x and y coordinate system. At least as close to a circle as possible. And then they give you all the different possibilities of the number of x and y intercepts. So this one has 0, right? That's the possibility for 0. So the question is this: is there a possibility of it actually having just 1 intercept? Oh, and then is there a possibility of having 2 intercepts? And then you should move on going.
What's counting just 1 intercept of x or y, or just 1 intercept?
X or Y, yeah, it doesn't matter. X or Y.
That's a lot of graph.
Things that make it big. Got it. Then you can check with your neighbor.
That makes sense. Yeah. I have absolutely no idea.
You say so.
I think Lawrence really figured it out, and it makes sense when you look it up.
A minute more. A minute more.
Wait, but
Trying
it's
to
still
see
just the
everything.
first one. So we're trying to do all the possibilities for how many intercepts. So yes, we figure out the one, but also other possibilities. That makes more sense.
Okay, sounds good. So, question, can you get one intercept? Is there a way to get two intercepts? How you doing? Just thinking, okay. Think some more and then maybe a minute more. Hakeem, how you doing there?
I was like, yes.
Or no? You know what class you have right now?
She has a free period, but I think that she's in her car.
A circle.
Got you. Boom, 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 boom. Okay. Back to you here. Gee. Okay, back to this. And another back to this. 1, 2. This is 0, 1, 2, 3. Okay. Sure. Go ahead. Let me explain again. Go ahead. What's the? Just wanted you guys to draw a circle. This is 0 intercepts, right?
No, yeah, Lily explained it to me,
Okay.
so it makes sense now, but I was just confused in the beginning, so I was like drawing just random stuff.
Gotcha. Noah, go ahead.
Okay.
Question. Okay, got it. Give me a circle that has 1 intercept. Okay, let's talk about it here. So,
No.
Can't you do
What if
it
we just
where
touch it? It's like, it just has
It doesn't have to go there.
Yeah.
No.
Like, I'm
okay, sure, no problem. So for intercepts, it does not have to cross. It just has to touch, right? It just has to touch one or the other. So for one, I think most of you guys drew something looks like this. It just touched 1 point right there. There's my y-intercept, or you hit it off the x-intercept, right? 2. 2 was something like this right here, right? There's your 2. Anybody got 3? What did that look like? 3. Ooh, anybody got 3? Joe? That's me.
like have it in the corner and it crosses over one.
Oh, okay.
I just did it kind of like 2, but scooched it over so that it touches the other one.
Gotcha. Okay, so here, and then it touches this one, comes back up, right? That's a deformed circle, but I got it. It's 3 still in there. Okay, cool. And 4? It's in the center-ish. Perfect. Yep, goes through all 4. That is so cool. Okay. Just so we know. Okay. 5. Okay, give me 5. So 4 is it, huh? That's it. No more than 4 for this one here. Okay.
I mean, just like acid trip and then there's 5.
5. Okay. Cam did something to you guys. Just want to say that. That's about it. Okay. Can go with the story behind it here. So do you guys know the quadratic formula, right? A squared plus bx plus c is equal to 0, right? Some kind of, just a quick little connection to this one. No, that's the beginning of just the Pythagorean quadratic formula is. Okay, good. This one is the quadratic formula, right? Let's see. This is what it looks like to begin with, right? This is the polynomial set equal to 0. If that's true, then the quadratic formula is right here. Yeah. Never mind. Not going to go there. That's okay. Not today. Let's jam. So that was intercepts, right? That was intercepts. Let's jam to the other thing. It's called symmetry. So the next thing to do. Yes, x squared is symmetrical about the y-axis. So symmetry just means can you fold this guy over? And if you can, it's gonna fold right on top of itself on the other side. Good, that's symmetry. What I want you guys to notice is this little piece right here. Notice if I have y-axis symmetry, the y's are exactly the same. The x's are different. So for y-axis symmetry, the x's could be different, the y's are still the same, vice versa, right? If you change it the other way here. So don't need to draw all these out, but I have this little piece right here. So y-axis symmetry, again, same thing, x is different. Y is exactly the same.
You have an x-axis symmetry that looks like a y-axis symmetry. How?
Yeah, for the x-axis symmetry, the y's are different. And this one's called
Like the
symmetry with the origin.
X-axis. Like, see how the y-axis is symmetrical and then the x, to make the x-axis look like a sideways y-axis.
because then it turns into the x-axis. Let's go this one. We got three, right? X-axis symmetry, y-axis symmetry, and symmetry about the origin. This one says this: if I have a positive x, positive y, I can also have a negative x, negative y. So both change. We good? So real quick here, how many symmetries? Trace is cool. Okay. So first things first, can you graph for me the x-axis symmetry with this graph? So yes, you're gonna have to graph this graph and then finish it off with the x-axis symmetry. So sketch the complete graph of this equation. That's the instructions if you want to write them down. And so as you graph this graph, can you give me x-axis symmetry? No equation, just base it upon the graph itself. So there's a graph. Complete the graph by filling in the x-axis symmetry. Oh, you know what? This is fun. This is cool. I'm going to do the rest of them as well, because we should be able to do this here. And this one's going to be y-axis symmetry. Give me y-axis symmetry. And give me symmetry about the origin. That would be fun.
I think that we have different ideas of what fun is. Such joy, never have I felt. I'm so-
I'll give you a little clue for the middle one here. I am taking this out to negative x to -4 over here. And 1, 2, 3, 4.
Wait, is x-axis and so confused? How do you see?
Sure. No, go ahead. Let me walk around real quick here and then I'll come back to this one. Go ahead.
Oh, it is.
So x-axis symmetry means what? If you fold it along this line right here,
Oh, okay.
you get the other graph. Y-axis symmetry, yes.
And the other one is the one.
No. Then the other one is if you fold along the y-axis, you get the same thing.
Oh, that's what I thought. I don't know at this point anymore.
That's right. Okay.
Good job doing that. Let's see. So y-axis symmetry, I think most of you guys are doing this one here. That means if you were to fold on the y-axis and you fold it, you would get the other graph. So if you were to fold along the y-axis,
Oh, okay.
you would get the other graph.
Okay, I think I have it now.
Cool. Okay, give you guys another minute here. And then first two are good. Yep.
Oh, so you do.
That's what I thought. Like this, that's not like accurate, but
So the y-axis would be along the
because they're
y-axis.
folding it along, yeah.
Stretch it together. They should match up. We've got it now. One more.
How do you fold?
About the origin, that one you can't fold, that's the problem with
Yeah.
the origin, that's no fun. So with the origin, now we have to think about a little more abstract, now we gotta think about negatives and positives, right, opposites and sames.
I don't know.
Okay, just a little bit more.
I just used them.
Now you share with. No. Okay, Joe, I just do. Where?
Wait, that was the order? Yeah.
Because whenever it is, it's because like usually they have this thing.
Ooh, okay, that one's cool.
So it's like if you folded it
Symmetry along the
wide,
y-axis
then
means
it would be
I
the
cut it
same.
along the
Yeah.
y-axis and it folds on top of each other.
Oh,
Not where it starts, but the axis itself. So think about folding y-axis.
I'm not ready to fold.
Because what you did is you folded it right here.
I do want that
Fold it
comfortable
on top of
stuff,
itself.
it's that was so.
So think about just a little.
The bars, yeah.
Joe.
We have those for breakfast and my mom was like, they're healthy, it's vegetable bars
And then there's.
with chocolate chips and sugar.
It's just this line here.
Wait, that's the best.
Okay.
Comfortable.
So if you don't know, that's fine too.
Funnily enough, Fruit Loops don't have vegetables in there. Yeah.
We'll talk about, because that was the most difficult one. But those two are very same.
It was no fun, we didn't get to do all of the stuff that I wanted, we just had so many different ideas. Like, she has a pond that would be really cool to do something at, and we didn't get to doing that. Because we got there and it was like beginning to be golden one.
Oh, really?
Well, like gradually started to do, so we got a lot of cool stuff, but not everything.
How long?
Like 3 hours?
What was this for your,
No, like this is fun, it takes so
Geometry,
much.
that's okay.
Oh, no.
Okay, class, let's go. First things first is, we're gonna do this one here. Everybody got this one. Everybody was okay with this? That was easy, right? It's folding along the x-axis. Folding along the y-axis, should have went like this. So if you were to fold this right here, just go like this on itself. Notice this little 1, it matches to here. This little 2 matches to here. So this little graph should match to here. And then it goes out like this. Good there. Everybody okay there now? Think about three people did not have that yet. So it's folding along this little line right here. Okay, those two, I think you can kind of imagine in your head, right? Those are kind of at least easy. The origin is the one that's not so cool. So now let's go back to this one right here. So if this is 4, 0, let's say this is 5, 1. Notice this guy is going to be 5, -1. Are we good? It's this whole concept of the y's change places. If sorry, yeah, it does. Yeah, it should draw more skinnier. So if it goes like this, no, it's saying that is a little too fat out. It should have went like that more so. Boom. Is that better? No. Okay. So then let's see. If this is 5, 1 over here, what should be the y-axis symmetry? -5, 1. Okay, boom. -5, 1. Okay, and if this guy actually is 4, 0, everybody okay with this being -4, 0 now? Okay, So now, this one's the one we can't really picture well in our heads here, but I know this guy is 4, 0. I know this guy is 5, 1. And what happens here, both numbers change signs, right? Both numbers change signs, so I got myself what? Negative 4, 0. I have this dot. What's my next dot? Negative 5, negative 1. So negative 5, negative 1. I think just based upon those two dots, I think we should be able to know where we're going, right? So notice on the first two, it's quite easy to do the folding part, right? Folding is pretty easy. Once you get to origin, then we got to think about the negatives and the positives.
You just fold it horizontally and vertically.
Diagonally.
Ooh, cool. Horizontally, so fold it along this guy
Except for that.
Yeah, you just fold both of them.
and then fold it along the x-axis afterwards here. Yep. And some people can picture it. Real quick here, how many can picture folding it X and then folding it Y and it's cool? 1, 2, 3, 4, 5, 6, 7. Okay, okay, got it. And somebody, let's see, Landon, he was cheating in the beginning, now he fell off. Okay, let's jam with this. So now, understanding the fact that it's just a folding, or even better yet, just this changing of the signs. Let's take a look at, again, more abstract. Here it is. We're going to use the algebra tests to see if this guy has symmetry or does not have symmetry. We good? So here's the test. The test is if I can put a positive negative value in here, it's going to give me the same equation as over here. So changing, we'll do the math behind it here. So putting in a negative value for y does not change the equation because I can still get this equation again. Does that make sense? So, well, let's try this one together. I think we'll be good here. So if I'm going to test for x-axis symmetry, I'm going to plug in, which one moves again? X-axis symmetry. Which one's the sign change? The y changes. Okay, I'm going to plug in this right here. I'm going to plug in a negative for the y. If it turns out to be the same exact equation, that means if I put a negative y or positive y, who cares? I still get the same exact equation. Let's see what happens here. So I put a negative in for the y value. Put parentheses here if you like. And what we do is we drop the parenthesis, right? Because after dropping the parenthesis here, we get this right here. And we're going to try to solve for y again. Yep.
Did you change the subtraction between x to the fourth and x squared to addition?
No, sorry, that's me.
Oh, sorry, I was just wondering.
No, thank you for picking that up here. I didn't start off well here. Let's see. If I were to multiply through by -1 to solve for y, the question is this. Is this the exact same equation that we had before to start off with? No, it is not, right? So by plugging in a negative into y, it has changed my equation around. Let's try the y-axis symmetry. Let's try this one. Plug in a negative in for the x. Let's see what happens here. In fact, you guys plug it in. Go for it. Plug a negative in for the x value this time. And see what happens. Plug in a negative for the x and see what happens. What do you tell me?
No, that changes 3. Because everything else is squared.
I don't think the 3 should change because there's no x to plug in next to that. If it goes 3x,
Oh,
then you
right.
plug it in.
Actually, then nothing really changes.
Gotcha. Okay, strangest thing. Look at this. I plug in a negative for the x. minus sign again, sorry, but place on. And I got square this one.
Could you just say plus x squared, because mine's negative transfers to power positive.
Ooh, let's
Because
check.
The X is, the X, we're plugging in the negative at, before we square it. So then we square the X and it's not a negative in the top. And then it's a minus that positive number.
I agree with Noah. So negative times a negative times a negative times a negative gets me a positive x to the fourth. This one's squared, right? Negative times a negative is a positive, so it leaves it like this, and I have that in my hands. Whoa, that is so cool. So hold on, did that give me the exact same thing? Okay, so I do have y-axis symmetry here. On my hands. And then do we have symmetry about the origin? Plug in a negative x, negative y. And see if I get the exact same thing over again. Let's see, plug it in.
Are you saying that the x is not x symmetry, so therefore it can't be the origin?
Mhm. Multiply it through across, and I get myself this, which is now that, which is not the same thing, right? Cool. Okay, so real quick here. So we started off by looking at graphs and folding them, right? Then we looked at the sign changes on our x's and y's, and now we got some algebra rules for this stuff. So all we got to do is really just plug in negatives for the x's, negatives for the y's, or negatives for both to check for symmetry. So we got ourselves some algebra tests that we've developed. Okay, so this one only has y-axis symmetry. We're good? Okay, all yours for the next one, just to try. Mark it, set, go. And this one's the easy one. You almost should be able to sort of think it through in your mind. You need a test for x-axis symmetry, then y-axis symmetry, and then symmetry about the origins of test.
Negative times negative.
I think so. Yeah, it's only been true
It's
since
slightly
third grade.
worrying when your teacher says, I think so.
Yes, that is true, Noah. Negative times a negative is a positive.
Okay. It's only been true since fourth grade.
Say again?
Yeah, we've only known that since.
Yep, fourth grade. We started multiplying negatives and positives because in fourth grade we did the multiplication table. Then after that,
Yeah, I just said
we did the
it in grade
negatives.
and actually let it correct.
that is a-okay. And O.
Oh,
Like no axis symmetry, is that right? Y-axis symmetry, how about this? I have no x-axis symmetry. I have no y-axis symmetry. Therefore, Elika, is that true? Therefore, it should not have any origin symmetry?
Well, no, because we negative times negative is a positive.
Oh, cool. Okay. So how is this different from this one? Let's see. If it had no x-axis symmetry, it did have y-axis symmetry. I think you said that it should not have any symmetry about the origin, right?
Yeah.
Okay. I wonder if that's true all the time. If you have x-axis, don't have x-axis symmetry, you do have y-axis symmetry. Does that mean you'll have not have symmetry about the origin? What a fun question to ask.
I don't think so, but there's probably some equation out there that will.
You know, always that anomaly, right? But you hate the anomaly, like, oh, you know, that one does work. Okay. Uh-huh.
No, it's like every rule has an exception, and then that rule has an exception.
Who has an exception? Double exception means you're back to the rule.
Every rule has an exception, has an exception.
Oh, gotcha. Okay. Okay, are we good there? Are we good with the algebra test for symmetry? There's the second to last thing to do. Yeah, interesting in mathematics, I think in my mind is the fact that math tends to be a way in which we function in our brains at sort of like almost like certain levels. So, right. So if you say things are symmetric or things are similar to one another, right? Or things are even the same, right? Sometimes they're the same in one way, but they're not the same in the other. Not just in mathematics, but in different ways. You know, if you say like, okay, there's two rockets that are rockets, right? From there, as you say, okay, yeah, they are the same as far as rockets are concerned. Now, are they the same as trajectory or not, right? Or the same as the fuel that they use, right? So you have symmetry in one way, but then you don't have symmetry in another. We break it up.
The second of the same type, they're launching fairly afterwards.
Mhm.
It's just been a couple of weeks, been like
2 weeks, Yep. Okay, guys, that's symmetry on our hands. And one last thing to cover is circles. There it is, circle equations. We looked at intercepts of circles. Now let's take a look at the equations themselves. So general or the standard form for an equation is this. It's x minus h squared, y minus x squared equal to r squared. And the h and k are the center of the circle. R, even though it's squared in the equation itself, r is the radius, even though r squared is in the equation. Okay, good. No, okay, sorry. Yep, tell me if I'm going too fast. So everything about circles, really, really quick. So at least write down the equation for it. And if you want to sketch the graph real quick here, go for it.
Wait. No, I can't.
You'll find out I can't either in just a bit. Got 2 more people, 3 more people still writing it down. think we can do this in 8 minutes.
Yeah, I can do people who can, not the compass.
Compass, I don't know if anybody can draw a circle perfectly.
Well, visually.
It's very close. Cool. Okay, let's jam. So work with this real quickly here. So first things first, can you write that equation there that we just started? Can you write it with the characteristics of this? The center being at -7, -4. I have a radius of 7 for this circle. You don't need to graph it. Don't graph it. Just give me the equation for it. Notice the equation itself has negatives inside it, right? There's a minus sign. So kind of careful with those because you technically will be subtracting a -7. And anybody talk to me, whoever has the answer.
Is it, in parentheses, x plus 7 squared plus y plus 4 squared equals 49?
Go with that. That's perfect. Good job. Are we okay there? So jam to here. The equation is, that's the x over here. H is our x value, right? But because it's a negative, so it comes in as x subtract a -7. At that point, it becomes x plus 7. And we go from there. We're good. Circles, super duper important in mathematics. Let's see if I can find a video about some stuff like that by Wednesday. Okay, are we good there? Pretty easy, I think. Just plug it into equation. That's pretty easy. Let's go a little bit more complicated. How about this? I have a circle. I have the endpoints. So I have a circle that goes to a line that goes to the center of the circle. And here are the endpoints, if you want a sort of graphic illustration of it here. So I know 1, 2, 3, 4. You don't need to graph it with me, but I know this dot here. Oh, that's fun right there. I know that this guy is the diameter of a circle. It has to be diameter because it has to go to the middle, right?
How did you get the radius from this?
That's my question.
That was also my question.
So if I have a diameter coming across here, like this, from here to here, stay up here. Go ahead. Triangles, that's right, that's for triangles.
No, I know, we need to use that to figure out how long that line is. And then with that line, you try to fill in that line,
But hold on, yeah, but then it's, if you divide it by 2, it's only going to give you the length of that half line. I don't want that. I want actually the coordinates of the middle.
Oh, I'm stupid, I want to do this. Oh, it's. Oh, yeah, I'm pretty sure it's x squared plus y squared 5.
No, I have the coordinates of the middle. If you think about it, everyone does.
I don't know.
I don't know.
I can tell you.
Is it wrong?
Let's see. I have this point and this point, right? What I'm trying to do is I'm trying to find the middle.
X1 y1 squared.
So you divide or subtract 4 from both sides, or basically add 4. Well, no, sorry, if you would add those two sides together, so add 4 to -4 and add net 1 to -1, then you get 0, 0.
Yeah, because we already could figure that out. So then
That's the
the
middle.
radius would be 5, right?
No.
Ooh, okay, let's go with it here. So to find this little middle, can you guys, I think we learned something called midpoint. Did we learn midpoint formula?
No.
What's the midpoint formula? X1, I think it's plus.
Plus y1 squared.
Isn't it y2?
Y-
Or no, it's no, oh, sorry, x and then the 2 below.
x2 divide by 2, right? Because you're trying to get the middle of the x coordinates. Okay, I think we're good there. So if I know the segment, right? I'm trying to find the middle of that line segment. I just find the midpoint. We're good. So let's do this one real quick here. So I have a -4 plus a +4 divided by 2. I have a -1 plus a +1 divided by 2, and the answer is 0, 0. Okay, so don't forget the division by 2, right? Okay, crosses to the origin. That's cool. So then I have, talk to me, Landon. What's the, what is it, x? True, we could have saw it by the graph, right? Algebraically, though, because that's what we like to do. We like to prove it algebraically. Goes to 0, 0. So everybody okay with this one here? How about this? X minus 0 squared plus y minus 0 squared. Will that give me the values there at least? Does that work? Those are my center points, right? And now I need to figure out r. And you guys said what? Okay, good, good. So from here, I think Noah's correct. I think what we could do is this right here. But now we can actually figure out a dot from here going to here. Right now, here's your Pythagorean theorem because I need to figure out the distance now here. So let me enlarge this real quickly here. This is 0, 0. This is 4, 1. And the question is, what is the distance of this line? The length of this line? Pythagorean theorem, huh? Let's go with it. Or the distance formula. That's right. Distance formula is
1
minus
x2
squared.
y1 minus y.
No, it's x2.
x2 minus x1.
X2 minus x1 squared. I got that. Uh-huh.
And then y1 minus y.
No, y2.
It's somewhere it's squared. Okay. Can you guys finish that one out? Go for it. Square root of 5. Are we sure?
Wait, but
I think I like that better. Uh-huh. Yuck. Okay, so that means this guy goes over here. Let's see, so we can finish this off with a minute left here. We got this one squared. Can you give me the nice equation? We can get rid of zeros, right? So give me the nice equation at the end. But it's square root of 17 squared. Just 17. There is the equation of my circle. Are we good?
17, right?
Okay.
Multiply by 3 times 2. Basically.
With 50 seconds left here, we are at the end of 1.2. We just need to do the graphs of them. So I'll leave that for next time. We'll just finish up with the graphs for 1.2. But all the rest of the homework you should be able to do.
So where
So-
are we going?
What do we get?
Second,
What problems?
60.
you should be able to get to up to 63 on the homework. 63 on the homework, and then we'll finish up those last two afterwards. Cool. All right. With that, guys, have a good day.